Alrighty, I am here. And it looks like I already got a couple people in here too. So, let's see, a little update from last week. Last week we were over in Mastercam, um, doing the programming to route out our carbon fiber frame after we did the prototype in a piece of acrylic on the laser. So, let's see. Mark Pryor's already making fun of me for being a little bit late, but it's kid's birthday dinner tonight, so you'll have to excuse my tardiness here. So, last week, there, last week we came up with this, which is just a piece of black 1/8 inch acrylic that I ran on the laser. And we ran this on the laser just to give us an idea of what it's going to look like and check for fit and part clearance, right? The laser's easy, inexpensive to run, material's cheap, right? And in just a couple minutes we can prove out our design without having to dig into a $400 sheet of carbon fiber. But this morning we ran this. Here she is, frame number 1, right? We've got our quasi-isotropic carbon fiber. And this, yeah, this is a stiff frame, right? It's under 4mm thick. I had the sheet, and rather than purchasing a whole new sheet, I just ran this first frame off of my existing sheet, which is like 3.3mm. So it's just a touch narrower than, let's say, we would want to go into production with, a full 4mm. But it's a really high quality sheet of carbon fiber. So it would be comparable to a like mid-grade 4mm sheet. Is that it's a really good layup, very stiff, and it's got a really great finish on it. It's just got just a little bit of a matte finish on it. It's not the super glossy stuff. It's a really good looking sheet. Anyways, I haven't done any filing, so this thing's still a little bit sharp. But I say let's bring up the video from today, and we'll go through a little bit of the setup. Let's see. Oop. There we go. So that's me getting started over at the shop, and everything seems to be working good on the stream. Cool. Okay, so I took the dust boot off just so I could get the camera in closer so that we could see what's going on. Normally we wouldn't do that because the carbon fiber, the dust from cutting these sheets is really bad for everything. It's bad for electronics, and it's bad for all the mechanical parts on the machine that on my particular router, they're all exposed. Cutting the carbon fiber creates a really fine dust. You try to move as fast as your cutters will allow to keep the dust down, but it's still it's a dirty operation. And the carbon fiber also has the wonderful property of conducting electricity. So when all your computer parts start sucking in the carbon fiber dust that's floating in the air, it's bad news for that stuff. So normally I would have the dust boot on there and the dust collector running, but I figured cut one frame with all that stuff off there so we could see what's going on. Let me roll that back a little bit. Pay attention. Okay, so I'm changing out the bits. I had a 90-degree engraver in there from the last job I was running. So I pulled that that was a 1/4-inch collet that was on. So I've taken that collet out and I'm putting in an 1/8-inch collet. I use these. I've just got a Porter cable motor sitting in my router right now, and I get these extreme precision collets that are made for that Porter cable. The run out is like 1/10, I believe, in those collets. They're all like graded and binned, so you can purchase whatever precision level you need. These would be the most precise because you're starting off with a pretty bad spindle to start with. The run out on a Porter cable is not great to begin with, so I got a set of collets that basically have no run out. This is the machine homing, so just like your 3D printer, it goes to both corners and touches off of a limit switch to find 0, 0. And now it's coming down and it's going to plunge onto that switch there. It has a little UHMW cap on it, and it's measuring the height of the cutter. So now that the machine's been homed, the cutter's been touched off, so it knows where the tip of the cutter is. I'm taking my sheet of carbon fiber and I'm putting spray adhesive on it. If you see that, pause this again. You see that sheet has clear film on it. That comes from the factory to protect it from scratches, and you can see the film is starting to peel off in the corners because I've used this. Cut my prototypes out of this sheet, so it's been on and off the machine a couple times, and the film is starting to pull off right there, and that's gonna affect a couple things later on down the line in a couple minutes here. But anyway, I've got this Loctite spray adhesive. It's they call it like a repositionable bond, so it's not super tacky. Normally I would use Super 77, but I wanted to give this a try from Loctite. It's a little bit cheaper than the stuff from 3M. So there I am. I'm just hosing it down onto the vacuum table here. And this fixture here, it's from a previous job, and it was on the machine, and it's going to do the trick, so I just left it on there. There was, I could pull it off the machine and stick the carbon fiber sheet down on that lower spoil board, but this has already been leveled off, and so I figured I'll just spray my sheet, stick it right onto here. So you see I sprayed the backside of the carbon fiber. I sprayed my vacuum fixture here. And I'm not going to try to hold on to that sheet of carbon fiber with vacuum because it's got so many holes in it at this point. But I'm just going to line the front edge of that carbon fiber up with the front edge of my vacuum box there, and just press down and put some pressure on it. And that's all it takes. That spray adhesive will keep that sheet from going anywhere, and it's actually pretty hard to get it back off of there when you're done, and that's why the film is kind of starting to pull off of the back of it. Here's the prototype that we cut out on the laser out of acrylic, and I'm just positioning it on the sheet to see where I want to set my origin so that I cut the part exactly where I want it. I don't want to waste any of this carbon fiber because of how expensive it is. So you can see I've kind of tucked the tuck that lower left arm in real tight to that little area to try to maximize my sheet usage there. I don't want to have 2 inches of wasted space around this thing. So I'm making sure that I line it up super tight. Yeah, I set my origin when we were in Mastercam to that lower left-hand corner. And right now what I'm doing is touching off on the MDF, right? So I've brought the router bit down, and I just started to touch the MDF enough that I see it kind of drawing a little bit of a line when I jog it back and forth. And then I zero the machine out at that height. So now the machine thinks that the top of our MDF is 0 for our height. And when we programmed the frame out of the carbon fiber, we programmed everything as a positive number above 0. So there we go. I set the origin in the corner, and here's the start of our program. Right, I've got that 1/16 inch end mill loaded up in the machine, and right now it's doing just a helix down into the material to give us that M2 clearance hole. So an M2 is just slightly bigger than a 16th. So I'm using this 16th end mill and a helix, which opens that hole up just a little bit above. Now you can see that my sheet is bouncing, and that's because the film has been pulling away in this corner of the sheet. And so you'll see later on in the video, there's going to be like a screw and a washer that shows up magically. So I stopped the program and I ran a screw in to keep that sheet from moving, because when if that sheet starts vibrating, it's just going to snap that end mill right off. But normally on a brand new sheet, a good sheet with the film attached properly, no problem at all. So there it is, ramping in for the battery strap slot. Now we're cutting out the clearance hole for the backside of the motor. Some motors have the C-clips in the shaft that stick out the back. There you can see how much that board moved when it plunged in. And there she goes into the crown. You can see the little heart cutout is starting to dance there. And I do something stupid right there. Put my finger right in there. There we go. So from last week, what we're doing with that 16th inch end mill is we're just ramping down into the material so that we're never going deeper than a 1/16 of an inch at a time. We're not plunging in and trying to cut that whole 3.5 millimeters of material. The cutter's just ramping back and forth and only taking a 1/16 at a time, so that our depth of cut is equal to the diameter of the cutter. That keeps the side forces low on the cutter. They'll last longer and you'll break less cutters that way. And same thing with this. It's going to make 3 passes to get around the frame. Last week we wrote the program with a 1/8 inch cutter to do the final cutout. I went back into Mastercam and changed that to 1/16 so that I didn't have any tool changes in the program. Mostly because I'm lazy and I don't like doing tool changes. So I just wanted to leave one tool in there and be done with it. There she is, coming around. So that's the first pass. That's only a 1/16 of an inch deep, and you'll see it plunge down another 1/16. It's going to go around again. Then I'll just speed the video up so that we get around this thing. There we go. Around it goes. And then remember, we left 4 tabs. We put a tab in each corner so that this frame doesn't pop out of place. And so right here, after it turns a corner, you're going to see it lift up and then drop back down. And what that did was leave just a little bit of material there to make sure that the frame doesn't break free while it's finishing its cut. With the 16th inch end mill, there's not really much force on it. If we were hammering on this thing with the 8th inch end mill, the part is more likely to move. Havelock says I would slow down and cut it at one depth. The reason that we don't slow down and cut it at one depth is because the dust, right? So if we slow down and take a smaller chip, we end up making a really fine powder that gets all over everything. So what I try to do is I use a depth where I can get the maximum feed out of the machine for that cutter, so that I'm pulling out like little chunks of that carbon fiber sheet and keeping the dust particles real large so that they drop to the ground real quickly and they're not floating all over the place. Because that stuff, even on the dust collector, the carbon fiber, it clogs the filters up like right away. I know, like on the vacuum cleaner, I use a filter that's made for doing drywall sanding, because it's real slippery paper that's on the filter, and that way you can knock that dust off of it. It's so fine that the paper and the cloth filters clog up like immediately. So yeah, they're taking the screws off because that front lip of that sheet was bouncing, and those tabs were so small that when I pull the sheet up, the tabs just they sheared right off, and I didn't have to go in there with the little clippers and clip the tabs. There she is. Just gotta peel that thing off of there and knock all that carbon fiber dust off of it. So that's it. Not too bad. Can you have the air blowing the dust away? Yeah, I mean, you can use the air to blow the dust away, but I don't like to blow it all over the shop either. You know, because the computers and stuff that are running in the shop, those filters all end up pulling the carbon fiber dust into the computers and stuff, and that dust conducts electricity, so you can end up like shorting out boards and stuff. So I try to disturb the air like the least amount of disturbance as possible. So normally I would just run the dust collector on there with the boot on there to pull all that away from the machine. But it's hard. So like the fine dust will go right through the filter on the dust collector, and you're kind of like blowing it all over your shop anyway. That's why it's good. Like there's good designs out there where you're cutting the carbon fiber underwater. You know, there's like basically a bed where you can put about an inch deep bed of water, the carbon fiber sheet down at the bottom, and then you can run around and you don't make any dust at all. You don't need to worry about dust collection, and all you have to do is replace the water, filter the water, or whatever. You know, let it go down the drain. Maybe, I don't know if the carbon fiber can go down the drain, if it's supposed to, if we need to filter that out. But anyhow, so not bad. It was pretty straightforward on this one. Like I said, I ditched the tool change just to make my life easy. Stuck with just the 16th end mill. The biggest waste of time on the machine that doesn't have the tool changer is doing those manual tool changes. You gotta, you'll pull it out. Sometimes you're changing the collet, then you gotta touch the tool off again. And with my scatterbrain, a lot of times I forget to touch a tool off or do something stupid like that, and it ends up ruining my whole day. So I just left the one cutter in there. Yeah, Havelock says fine milling clogs up his filters. Brass makes some nasty dust. Yeah, I could imagine. I've only cut brass on the manual mill. I've never cut it on the CNC. I wouldn't mind doing some sort of brass coin or something like that. That would be a fun project. I don't know. Anyways, stop that. Cool. So that was my day over at the shop today, getting our little frame cut out. Like I said, there she is. pilots, our little 4-inch. I don't know. Do we even have a name for this guy yet? We got to come up with a creative name for like my files. I call it the Stream Quad 1. 4-inch Stream Quad. What sort of filter? If, Matt Fender's asking me what sort of filter. You'd probably be the person to tell me what kind of filter it is. On my dust collector, I don't know what it is. It's just like a heavy fabric. I'm not sure what it is, because it's made for wood dust. And then in the vacuum cleaner, which I use for like the vacuum hold down and then for cleaning out the machine, that's got a filter in it that has like I said, it was made for vacuuming up drywall. And so it's got like a what was it? Not Tyvek, not Gore-Tex, something like that. It's like plastic. It's super slick. And so it doesn't get clogged up so easy. You know, all the stuff just kind of, you knock it and all the stuff falls back off it because the filter's so like smooth. Oh, it basically feels like plastic. Maybe Fender can find me a couple yards of fabric that's like really good for carbon fiber dust. Or maybe we can have a build night and we can figure out how to make a little water bed for the machine. Polyolefin filter, that shiny, maybe not shiny, but yeah, that plasticky type filter. Yeah, let's see. Desktop, SolidWorks. There we are. This is the other little project that's going on. Our baby bando here. Our 124 scale version of Riverworks. So this is what I'm working on for this weekend, is getting this guy halfway there, maybe. I like to have it assembled in blue for our races over at the new track this weekend. So I've got all the materials and I got my 3D printed parts printed out, and it's gonna be time to assemble it. I gotta assemble it and paint it tomorrow. That's my chore for tomorrow. And I teased you guys with a picture of a part on the 3D printer, and that's that part right there. So I was trying to figure out how to fasten these 6 tubes together. Like I was gonna run a bead of glue down these tubes and then clamp them, and then I thought that was a really big waste of my time, and so I just printed out this little washer type thing, and so that I can run a 1/4-20 bolt through these things in each corner and just bolt the whole thing together. And if I'm still like getting light coming through these tubes, then I'll just run a bead of caulk down the seam and then paint. Teabag says this model used for 3D printing. What model? Which model are you referring to? Our baby bando here. The baby bando's big, so this thing is 5 feet tall, I think. 63 inches, so yeah, just over 5 feet tall right now. It's a 124 scale. And that just worked out because these 12-inch tubes for concrete happen to be exactly like, not exactly, they're like 24.9 or 23.9 to 1 scale. Okay, Teabag, I'm new to the channel. I'm assuming you make 3D models for 3D printing. Yeah, yep. So what we've been working on is everybody in chat has been helping me design. Well, not helping me. I'm trying to teach the CAD, and I'm teaching SolidWorks and how to program the machines and how to do the 3D printing, and we're doing laser cutting and routing and kind of everything that's related to drone racing, FPV, freestyle, and stuff like that. So chat came up with this 4-inch frame. And so we've been working on this together, and we've been 3D printing, if I have one handy. So I don't know if you can see this guy here, but we modeled up our little camera mount and 3D printed that out of TPU, and we got a little 716 in there for our friend Havelock. And then we moved and did a prototype frame out of acrylic, but we did this on the laser cutter, like a kind of an oversized desktop laser cutter. And then after we did that prototype, we went and we machined out our carbon fiber frame on the router. So these frames, this is going to be a drone racing frame. So first person view drone racing, right? So this guy is going to get a little set of motors, a little camera on the nose, and then the pilot is going to put on his goggles, basically his VR goggles, and he's going to be looking out the tip of this quad here. And that is going to be one of the racing quads for this summer. And on my screen here on SolidWorks, we're working on one of the racetracks for the tiny indoor drones. And this is basically an old grain elevator that's downtown Buffalo nearby. And so we're using that as part of the track. And let me pop over to, let's see. Oh, here's another project. There's Multi-GP's regional qualifier track. I loaded that up into SolidWorks so that I could start looking at camera placement for this summer, right? I wanted to figure out where we're going to stick our cameras this year for our qualifier when we live stream from the track. So you can see I've got our pilot pit tent right here, and there's our starting blocks there, and the start finish gate right there. And I've also taken and mapped out the fastest route through the track, which is this blue line here. And SolidWorks is telling me that it's about 1,000 feet to get through the qualifier. So this line, if you can see at the bottom, is 1,069 feet. That's how long this year's regional qualifier track's going to be. So Fender says, good, they put the pilots in the corner. I don't know. It's up to me where I put you guys. I could put you guys wherever I want. What I'm looking at from, like the race director standpoint, or the event coordinator, whatever you want to call it, is I want to, put on a kind of a good show for everybody too, because we want to get more people involved in the sport. So I'm looking at, okay, if I put the pilots here, if I put the launch pads, there, and I put my cameras here, and here, that like we can look down the track, right, and we can see the launch pads, we can see the pilots, we can see the start finish line. So we should be, we should have a really solid live stream coming out of the qualifiers this year. So I've been collecting all this junk for the bando, for the qualifiers. We're getting carried away. I've got 2 Night Owl DVRs that Scully found online. I got those coming in on Monday, so that we got two additional DVRs and a whole bunch of stuff. I've got a stack of boards that I posted a picture of, so that we can make Delta 5 timers. So we're gonna have a whole stack of Delta 5 timers for the track too, so that I can see. We're gonna get more updates as to like pilot position on the track. Right now we have a single timer, and so we get I get an update every time you guys put in a lap, so I know who's in first place when you cross the finish line. But now I'm gonna add like 3 more timers so that the computer is gonna update 3 times across the track with who's in first, who's in second, and it's also gonna tell us now how fast everybody's going, because once you have 2 timers, if you measure the distance between the 2 timers and put that into the computer will spit out everybody's speed. And so that's going to be really cool to post all the top speeds coming across the track. We'll set up like a timer, one on each end of a straightaway, and get top speeds in a speed trap. So that's going to be cool. Let's see. Let's go pull up our stream quad, because I think we've got a couple things that we got to do. I think we need a top plate, right? Stream quad. All right, cool. There we are. Matt Fender says, did I get the immersion power tester? No, I was looking at it this morning. I'll probably get a few of them. The price was good on them, and I don't see any reason. I was kind of thinking about the RF Explorer, especially with some of the software that you can load up on a laptop. For the bando, I've got to check everybody's power output because we've got the 3 tracks running at the same time. So I have to make sure everybody's, within a certain tolerance there. And I wanted to set up a table with the RF tester and a spot for the quad so that we're testing every single quad equally. I don't want to kind of just wander up to what we think is like a problem quad and test each one differently. You're testing this one over on that side of the track, this one over here. When the pilots check in, part of the tech inspection, we're going to check for fail-safe, and then we're going to check like video power. And so I'm just going to have a spot on the table. You set your drone down there, set it for what you think is 25, and then fire up the power meter and make sure that you're not way under or way over as part of the check-in process there. So I don't know. We've got our list of volunteers, and that's gonna be one of the positions for the volunteers, is to run the tech inspection. Havelock says, safe to assume we'll be able to test this stuff out during the spring races? Yeah, definitely. So, like the gear, we're collecting the gear. I'm gonna bring out like a scale, so that we are weighing our 250-gram quads, make sure like those are underweight and stuff like that. And so, yeah, we'll get used to everybody, figuring out the fail safe. We want to make sure when you got like 100 pilots, we need to know that if your remote dies or it loses its link, that the quad will fall out of the air and not like full throttle downtown somewhere. So, but that is becoming basic standard race stuff. When we were out at Muncie for the riot, it was the same thing. Everybody on check-in, you have your quads ready, no props. Take your props off. So like when you show up to the bando, so you can save time, have your props off already, and you'll check in, get your wristband, get your passes and stuff like that. You'll go down the line to the tech inspection, and whoever's volunteering at that table will take the quad. You'll fire the quad up, fire your radio up, arm it, turn your radio off, make sure the quad, we want to see that the quad turns off and doesn't like go full throttle or something like that. And then we'll, check the RF output on it. And then your quad will get tagged. So you want to make sure that every quad that you want to fly gets tagged, because then the people running the flight lines are going to be looking for those tags. Anybody that's flying a quad that hasn't been tagged will get in trouble. And that's just to make sure that it's a good experience for everybody. When you run into like somebody that, it's not about people like trying to purposely be bad. It's just, we don't know. So, some of the stuff that comes in is labeled as 25 and it's putting out like 200 milliwatts and stuff like that. And the owner, you don't know. There's really, there's no way for a lot of these people to figure out if their equipment's legit or not. So it's just a way of, making it good for everybody else. Not trying to dump on anybody's like bad equipment. It's just like, when you have one video transmitter out in that group of 100 pilots, it can make it a tough day for the other pilots that are flying with that person. So yeah, that's what we're up to. For the quad, what do we got here? We got to get a top plate on this guy. We already cut the frame, so I'm thinking the top plate should attach to those standoff screws. I don't know. What do you guys think? Fender says the craziest thing I ever saw from a safety standpoint was IB crazy crashing something, then having to go flying, have it go flying into Jason Cole's car. So he hit Jason's car. Yeah, oops. We've seen it. I don't know if you come out to the field often enough. We've seen the quads take off and go home, and we don't know where it is. Not sure where they want to go, but they leave us. They disappear up into the sky, never to be found again by us. So there's a couple people in the group that could tell us all about that. So we're gonna try to avoid doing that when we're like downtown. That's one thing in the field, in the woods and stuff like that. But hopefully we're at a point with our group that we're gonna have a really good time and won't run into some of the stuff that like 2 years ago we saw more of. Yeah, a crazy Y6 that only kind of worked. That kind of does sound like I'd be crazy. I love his stuff. I like what he does, and I don't know, when you're out there like that, yeah, you come up with that crazy stuff like that. Yeah. So far, how many quads have we lost at Riverworks? Right, Mark? What are there? 2 quads at the bottom of the Buffalo River right now? Yeah, well, that was a proper failsafe. That was a good safety lesson, right? The quad lost the link to the radio and fell into the river. That's exactly what we want to have happen. The opposite of that would be to have that quad full throttle, on its way over to the Seneca 1 tower. Bad build. No. I say really poor decision to go through a corrugated steel building with that quad. That's pilot error right there. The pilot in control, especially a 107 pilot, should have identified the potential safety hazards at the flying site. I wish we had DVR of that in the goggles. If we can ever recover the camera that's at the bottom of the river, the footage, I'm sure, is beautiful. Fortunately, the Buffalo River is be a really poor choice to dive that. So if anybody is really into remote vehicles and wants to build an open ROV, we got like your first job lined up for you is to recover 2 quads from the Buffalo River with your open ROV. So just something that we should put out there. I know Mark and I have talked about the open ROV because there's so many wrecks in Lake Erie that we could be exploring during the summer. I think it's a really good idea. They're still a little pricey even as a build it yourself, but yeah, I don't know. I think we'd have a lot of fun. It'd be the pinnacle of our nerdiness is to have land, air, and water. Okay. Anyways, focus. Top plate. All right. Let's throw a new part into this assembly and get this part top plate started. Oh, new part. Okay. Edit this new part. I'm going to select my top plane there. And we want to give our camera a little bit of protection. So I was thinking that we should have like a couple little like bullhorn type things coming out of this this top plate. I'll start with just a rectangle. And maybe I'll extend it out here. Yeah. So I'll make the rectangle like that, and then I'll like cut away the area for the camera. So I'm gonna put a center line on this thing just to make it real easy for me to make this symmetrical. And I'll dimension the width, which is currently in inches, but that's okay. SolidWorks will let me type in anything, say 25 millimeters, and it'll do the conversion for me. That's a little narrow. 28 millimeters. Sure, 28 millimeters. All right. And how far back do we want to bring this? We can kind of bring it back. We can bring it back far enough to give us some space to mount the receiver. I think that's probably a smart way to go. What is that? Is that 40 millimeters ish? And then our front for camera protection. And I missed. Measuring from the origin up to the front. And same thing, like 40 millimeters. There, that gets out past the front. And I don't know that we need a full 4 millimeters for this guy. Call it 2 millimeters, perhaps. Not add too much weight to this quad. So, like a 2 millimeter top plate. Okay, so now I'm going to move it. I drew it on top of the other parts so that I could get my sizes right. Now I'm just going to move it into position, and then I'm going to mate it so that it can't go anywhere. So I'm going to snap the front planes together. I'm going to snap the right planes together. Okay, now that those are attached, it can't move forwards or left to right. It can only move up and down. And so let's say rather than this nut here, if we used a standoff, I'll delete that nut, and I'm just going to copy my standoff up there. Attach it to my stack. There we go. Okay, so if I use a standoff like that, then I will put this board on that standoff. So that's our height there. Okay, now the board is fully constrained, so it won't move anymore. Next thing I'm going to do, I'm going to go back, edit that part, and I'm going to put the holes in for that 20 millimeter stack. So we're moving over, bringing up my metric holes, ANSI metric. I'm picking screw clearances, and I want M3, a normal fit. You can pick a close fit, so a super tight hole, or a super loose hole, right? So depending on what kind of tolerance you need. I'm just going to go with normal, and I'm going to go through all material, and then pick my positions. So I'm just going to pick those 4 points. There, there, and accept that. Go back to, whoop. Now we wait because I hit the wrong button. Don't want to render it. Thank you. Okay. So, there. Now we got our hole chased through the board. We have to get longer screws out. So let's find our base screw, which is that one. I'm gonna select the tip of that screw, which brings up my little green arrow there, and I'm gonna pull that up. 25, 30 millimeter screw. Probably about the longest you'll find. I think you can still get like a 35 millimeter, but the longer you make that screw, the harder it is to find a source to buy those things. So 30 is not too bad. That's really as long as we should go. And I just need to add that standoff to my pattern. So we're going to add that as well. It's going to populate all the other holes with that standoff. I don't know. We might have to rethink this method of building because it's dangerous for the boards for us to run run all the structure through those. If we hit that top plate on a gate, it's going to be bad news for the flight controller. Let's see. I attach it to the stack. Yeah, it's going to put a lot of force on that. Like this, I imagine this being a steel screw at this point. You know, maybe no, not aluminum. This would end up being a steel M3, right? So that's going to be strong enough. It's just a matter of we don't really have anything to help with the impact on the front end of the quad. So yeah, if we smack something with the front of that quad, it's gonna shift everything back pretty good. So we should probably add like another. We got to find like another place to put some holes so that we can add some additional fasteners in there, because this is not the ideal way to go, but I don't know. We work fast and we solve those problems later. So anyway, let me go back in here, edit this part, and I'm gonna put a cut in there for our camera. And just use a slot feature and draw a slot like that. And make it about the width, a little bit wider than our lens, like so. Yeah, let's see. I should probably change my units to millimeters now. Millimeters. Okay. 16 millimeter. And about 15 millimeter back. Yep, that should allow us to go vertical. Ooh. We're hitting our camera there. We have to solve some more problems here. Anyways, let's continue on with this. I'm gonna finish this thought and then see what we have to do to improve it. Right? So right now, what's happening is my camera is interfering with this part. You can see that right there, we've got a problem. But if I make this hole wide enough to fit the whole camera, which I believe is 19 millimeters wide. Okay, if I make that 19 millimeters wide, our little horns are really thin. How thin are they? Click on that. They're 4.5 millimeters wide. If this top plate's only 2 millimeter material, those would snap off pretty easy. So then what we would probably do is add some material to the outside, which, yeah, that's a kind of a common look. Add a little bit of material out there. I wonder if we put enough TPU in the center of this thing, if it would be impact resistant and just kind of go back to where it was after it gets hit without any issue. Hmm. That's an interesting thought. Yeah, boy, I've got a little idea. Remember to make this wider and then knock the center of it out. Put a whole bunch of TPU in there. Get wider. It's still hitting our camera. 20 millimeters. That's better. There. Mark Pryor / Bull FPV style right there. Only one of those two pilots actually knows how to fly. And oh man, we still hit the board if somebody wants to fly like Marky. Gotta take a ton of material out of there. Huh. I just checking to see if everyone's paying attention in the chat there. Just want to make sure you don't fall asleep like last week. I don't know. Really that bad? Man, I don't know. Now I'm kind of thinking that this little this camera mount should have been integrated into the top plate. Wow. Wow. Oh man, can I screenshot that and send that to Bull? That's a good one. Mark says that he can't believe that I think Bull can't fly. That would indicate that Mark knows how to fly. I don't know. You got a lot of proving to do this summer. I got a lead on a building for indoor 5-inch. It's a small little thread, but I'm gonna be pursuing it because boy, it would be wild if we had someplace. Anyways, we still have to enjoy our new little spot in Boston here with the minis. So I've got the new track for at least 2 months. So I have it this month and next month. So we got like 8 weeks in there. I don't know if Bull's ever run a quad into the river. How many quads has Mark put into the water? I don't know. Mark, will Mark admit how many quads are in the water right now? I know who he's gonna blame. He's gonna blame me for designing them poorly. I designed them to be attracted to water, specifically attracted to open bodies of fresh water. Yep. 2 quads are in the water right now, and how many quads have been in the water that are no longer in the water? Actually, it's the same. Yeah, it's still going to be 2. That's right. Because that quad that's in the Buffalo River, that's the second time that it's been in the water. Hey, at least we got footage, FPV footage of a fish swimming by. That's pretty epic. Okay, let me see what the heck we're going to do with this thing. I'm going to edit this sketch here and say that that's not the shape that I want. I want probably just a rectangle, and I'm going to make that rectangle symmetric like that, and we're 20 millimeters wide, and you know what, I'm going to pull my depth from here. Okay. And then we would end up just putting some fillets in those corners. There, right there, 2 millimeter, 3 millimeter, 3. Not bad. We're still swinging past it and not hitting it. It wouldn't be the first time I got all the way done with a quad and the props ended up hitting part of it. In fact, we even know some production quads that have problems like that. So we gotta go wider yet. How wide can we go? That? Sure. 35 millimeters is where we're at now. 35 millimeter. Now, what I'm thinking is if I blow this whole thing out, right? So if I throw a big hole in the center of this thing, instead of those holes, right? Am I thinking properly? I don't know. We'll see. Let's finish this thought and see where it takes us. So I'm gonna cut a hole. Let's make this guy. We're not gonna be symmetrical. Let's be longer. 30, not 3, 30. All the way through. And I'm gonna fill it all those inside corners there. Save that, go back in here. Now, if I do that and I put like a TPU part in here instead of like these standoffs, is what I'm thinking in my noggin right now. And then our battery strap will come up. We just come over the whole entire thing and we'll put like a nice little spot for the strap to come through. Let's do that. I'm gonna insert a new part on my front plane there. What's that hole? Make sure that I'm drawing on the top plane of our new part. About that big. There we go. And extrude that. Like 10 millimeters tall. Okay, I'm just making myself a little chunk to start with. Put that up there. Okay, so I'm diving into my part here and edit this sketch and clean that up. Right now it's floating in space, so I'm just going to give myself a little construction line, corner to corner, and I'm going to take the origin and snap it to the midpoint of that construction line. That way everything stays symmetrical for me, and that's going to be 28 millimeter by 30 millimeter. Remember that from just a couple minutes ago there. Change my units over to millimeters. I default to inch, even though 90% of what I draw is millimeters. Okay, so I'm envisioning that this is like a TPU part that we screw into, and that holds everything together, and it acts as a little bit of a shock absorber. You know, helps to actually protect our electronics below. So like if this top plate takes a hit, the TPU is going to soak some of that up. Interesting idea. We'll see how this works. How about we name it the BM Bandit? You know, I love Buffalo Multi-Rotor, but I really hate that the initials are BM. You know, it's not great. I love that if we were like, you know, if we had something sweet like, you know, DMR has a nice little acronym, but you know, BM, that's a tough one. If anybody doesn't know Buffalo Multi-Rotor, they're gonna think it's something else. And I'm pissed that we've got that other quad, right? The oh, what's the Bando quad? Somebody's got a Bando quad, and it's got a really nice name. What the heck is that? Bando Slayer. I was so sad when I saw that quad with that YouTube video, Bando Slayer. That's perfect. That's the perfect name for what we're trying to do this summer. We'll have to come up with something else, something greater, more epic than that. Let's see. I gotta locate this guy in space here. Again, I'm gonna just kind of like take those planes, right plane to right plane, bond them together, and front plane to front plane, bond those together. And now she's stuck to that part. Both those parts are stuck to those two planes, and so they can't go anywhere but up and down. And I'm gonna like extrude little standoffs out of this TPU part. And what I think we can do is if we undersize the holes in the TPU, we can just screw right into the TPU and draw the top plate right down into it. Havlock says he'll keep suggesting names. He likes naming stuff. So far, you've got you got the 716 on here. We do have this heart and crown thing. That's like number one right now. We got to figure out like what do we call this thing? Like what's gonna tie in our heart crown theme? Um. Let's see. This down to the thickness of the carbon fiber, 2 millimeter. All right, watch what I'm thinking. So this is what's in my head. If I take the front plane and give myself a little drawing here, making myself a construction line, and I'm gonna just pull an arc from there. Come on, mousy mouse. There we go. Cool. And set my height. About 10 millimeters is what I was thinking earlier. I'm gonna mirror that sketch. Hey, where'd my dimension go? 10. And this arc, boy, I don't know. Maybe I'll just dimension the width, 40. Okay. What's the width of our battery strap? I don't remember. 18? 18, let's 18 millimeters. Sure. Okay, so we got that. And then I'm going to extrude again. I'm going to offset this curve. Offset that curve up a millimeter. Yes. And bring a line across. Extend these. There we go. Use the little trimmer tool. Trim that off. Trim that off. Oh, we're broken. A blue line means it's not fully defined, but we'll fix that by making it coincident right there. Okay. And I'm going to extrude that out past the front. How far do I want to go? Let's say I want to be, I don't know, 2 millimeters past that surface there. So 2 millimeters past it. Oh, there we go. Okay, and then I'm going to take that and I'm going to mirror that feature across that front plane to put the thing on the back. Can't find it. Oh, I know why. They fixed this in a later revision of SolidWorks. Mirror doesn't work because we're doing an offset. So let's just do blind, 9 millimeters, 8 millimeters. Sure. Okay. Now I should be able to mirror. There we go. Okay. This is kind of where I'm going with that. And then if we like put like a small fillet on these guys. We have to do one at a time. Like that. Something like that. And then on the bottom, I'll put like I'll like build the standoffs right into this thing. Keep my eye on chat. Chat over there. The blackjack. Not bad. I'm okay with blackjack. Off the top of my head, I can't think of any other quads that have blackjack. Hmm. I don't know. What does the rest of the chat think about blackjack? I think it's a pretty good option. What do you typically, is the ace typically what's right? Ace of spades type of thing. We've got the heart and the crown. That's kind of like a Banggood Crazy Pony version of a blackjack, right? 6mm. And we'll make them 6mm long. And then what I'm thinking is we drill these out. And so instead of a clearance hole, we're going to a tapped hole. And SolidWorks is going to do the figuring for us. We'll say that's we want an M3 hole. And we're going to go blind 6mm deep. Perfect. That's like your default settings for an M3. And I will snap them onto our little standoffs that we extruded out here. Okay, and if I recall correctly, these need to be filleted. And I think they were 3. Okay. Let's bounce back and see what this guy looks like. Okay. We have no spade. The spade would help. So spade on the top plate? I think so, right? Let's extend the back end of this top plate and throw the spade up there. Oh, I'm so sad that that heart and that crown is buried like that. I'm really kind of attached to it. It's so odd. Like it's something that I would never have thought to do. I think that's why I'm so attached to it. Anyways, okay, so here's what I'm thinking. Like we get a TPU part like this, and maybe we could think about like some aerodynamics on this guy. But anyways, by doing it this way, I think I need to make a little bit of a feature in order to keep this, like it needs to be like snap fit or something like that. The top plate needs to like pop in there and stay put and not fall down, but that's kind of what I'm thinking. This is all TPU with like a real light infill. It'll have just enough mushiness to absorb a lot of impact, right? You kind of can slam into stuff like this, slam in this way, break those little fingers off, and still protect our camera. Yeah, that's kind of what I'm thinking. Anyways, let's put it where it's supposed to go. So I'm going to mate that standoff down. And I got to adjust the length of those screws back down. Save before we get too carried away. And bring up section view. Find the screw. There it is. Okay, so right now that screw goes way into the material, right? So where's our countersunk screw over here? And if I click on it, there's my green arrow. And 30, 25, 20. Back down to 20. And 20mm is a wee bit short. It's not enough. Let's go up to 25. 25? Perfect. We just got to extend that drill hole a little bit, and I think that's a good fit for what we're doing. Cool. Come out of my section view. And let's edit this part and make those holes a little bit deeper. I mean, we can make these holes through holes if we really wanted to. Let's just add like a millimeter or 2 to that. Length 7. Make that 9. Poke out the top. Nope. How deep are they? Let's look at a. Oh, we got plenty of room before we hit the top. Okay. I'm thinking we need to make this part a little bit more aerodynamic. Even though quads, I don't know, not much aerodynamic on the quad yet. Look. Okay. No, there's no room to extend that. All right. So I'm going to take my right plane, do an extruded cut, and I'm just going to come in and go like that. Give myself like a little lip here. 1.5 millimeters. Sounds good. And the arrows go in the right direction, so when I cut it, we are done with that. Beautiful. I'm going to leave the back alone for now, and maybe we can come up with something past that. I think that's good for right now. Maybe we want to chamfer these things a little bit just to avoid some of the components that are on the board flight controller. So I'm gonna get carried away. We can even do the same thing up here to make these little standoffs stronger, right? How much room do we have before we hit the edge of the sheet? Can we do a full millimeter? Yes, we can. Okay. All right. That's working. It's working. Let's get this thing narrower. Where's our control? This guy. 40. Let's start bringing this. Let's start bringing this back in. 38. Let's see what that does. Still wide. 6. No. Do I want to make sure it comes past the edge so that the carbon fiber is not cutting the battery strap? I think so, right? Go back to where we were. Yeah, 40 is just past the edge of the carbon fiber. 9. 8. 39 to be safe. Okay. All right. We don't want our battery strap rubbing on the edges of the carbon fiber right here. That's just going to wear it out prematurely. Avoid that. This sheet should have a nice looking front end here. Let's round these corners over. Do that now. Like that. Okay. Let's take a look. Chat. Kevlock says if we could add a Smarky style fin, that would help the quad turtle. That's probably too shallow right now to turtle, right? What if we did this with the video transmitter? Can we like integrate the VTX into a smart fin? Something like that. That. Like that. Can we do something like that? Encase this in a little shark fin. Actually, if we slot that carbon fiber, we can drop it down. Smart fin, you like that? Oh, we're coming up with all kinds of cool stuff now. Setting the Buffalo multi-rotor trend. Everybody this summer's got to have a smart fin with your drone number on it. That's part of the spec. Part of 250-gram spec. Got to have a smart fin with your number on it. We know what number Havelock is, so You guys are gonna have to pick something else. Um, write that down. Write it down, Benny Mac says. Smarkfin. Man, Buffalo. I don't think enough people understand just how much Buffalo has contributed to the drone industry. You got turtle mode, Smarkfin. There's a lot going on in Buffalo. So this summer we got to prove it to the rest of the world just what's going on over here. Benny Mac. Benny Mac's number 2 because his initials are BM. Oh man, there's so much BM in this club. It's ridiculous. What else do we got? We gotta put this big chunky receiver somewhere too. I'm sorry, but this is probably the receiver I'm gonna stick on the quad for now in order to test fly it. So I gotta find a place for it. I got a couple of these. Hmm. Boy, if it could stand up in there, that would kind of be nice. Of course, the wiring's going the wrong direction. You know, what receiver are we gonna use in this thing? I mean, I'm on Spectrum. Mark, you're on Spectrum, so we gotta, we gotta find space for a Spectrum receiver in there. And I think those the really tiny nano receivers are possibly the cause of some of that brownout that results in wet quads. I think we are better off with the longer antenna receivers. Everyone else is gonna have Tyrannus in theirs. Hmm. I guess the quad doesn't. This. I'm surprised at how low profile this guy's turning out to be. Well, let's. I gotta set the material for this thing so we keep track of our weight. What's our material here? Not specified. Carbon fiber. There we go. But that gives me a headache to stare at that, so I delete that silly texture and I just make it like a dark gray. That'll remind me what that's made out of. Perfect. This TPU part's gonna be way overweight. Oh, maybe not. I don't know. What does it weigh? Evaluate mass properties. 9.5 grams. That's probably under. That's probably underweight. I'll leave it. We'll call that thing 10 grams. How much do we weigh? That needs to be updated. How much do we weigh right now? I think we're over. Yep, rebuild. 275. Oh, we're way over. This is a terrible 250 spec quad. What the heck are we doing wrong? This guy's gonna have to compete with the big boys, not the little guys. That's okay. The smart fin adds minimum an extra 10 miles an hour. Benny Mac says you can donate a DSMX Pro half a kilometer, 0.8 gram receiver. Interesting. That's a huge. It's not really that big of a receiver. Like, I use this on my quads. It's a 4-inch quad. It's a pretty small quad. I don't know. Like, that's a micro camera, right? So, yeah, I guess it's a little bigger than the micro camera. Do I have a receiver sitting next to me? check my little box here. What's in the box? Well, this quad had a Spectrum receiver on it, but it does not appear to be part of the stack anymore. I don't know. This is my F40 quad with a Naze 32 board on it. What's left of it? I gotta put that back together. I gotta replace the flight controller and put that back together. I like the speed controllers. What are they? They're the XS30 amp DYS ones. They're cheap. Good ESC with a nice big heat sink on them. I don't know. I was running the 5.5-inch 2-blade props on that thing, and I love the way that thing flies. But the receiver I must have stole for something else. What do I got on this quad? Ah, there's the orange. Little orange receiver on the back of this one. That's one of the ones with the really long antennas on it. They're hanging off the end of there. I don't know, both of those are in a plastic case. I guess they're a little bit on the large side these days. Mark, what's Mark saying? Decase it. Yeah. Micro backpack VTX. Ooh, backpack VTX. I was gonna throw one of the Lumineer things, one of those newer ones on there with the MMCX connector on it. That's what I was thinking. Actually, I don't have any antennas drawn up for this. That's gonna be another thing. Is where the heck do we put that that antenna? Well, I suppose if we're smart finning it, we put the antenna up. Ooh, do we put the antenna up like this, and then like curve the coax around the leading edge of the smart fin, then have the clover leaf in the back or something? I don't know. What's going on over here? You guys can't see that. This might turn real bad. What are you doing? What are you doing? What are you doing on my bench? Huh? What are you doing? You're just up here to annoy me, aren't you? Let's see. Okay, Mark, can you cut the TPU battery strap thing and fit inside of it? Yes. Right? So if we put that, we mount that to our top plate and then like slide it in here, hide it right there. Like that. That works. We just gotta make that just a touch bigger, right? Is that where we want it, or should we put the VTX in there? No, the VTX will melt the TPU. We learned that the hard way. Yes, we'll throw the receiver in there. Okay. This is probably the biggest receiver that we're going to come across. So if this fits in, anything will fit in. We need like 21 wide by 6 or 7 tall. That should work. Oh boy. Oh boy. Excuse me. Oh boy. Oh, no, don't go back there. Nope. No. There we go. It's amazing that we get anything done over here. Okay. So we're going to punch a hole in the back of this thing we can slide that receiver in there. Okay. And that was about 07 tall. Now we can make it a tight fit, right? And 21mm wide. And this thing's going to be all over the place. We want to make sure that it's centered, so I'm going to select the midpoint of that line and make it snap to the midpoint of that line. There we go. And we're going to bring that forwards. So 30mm. Sure. Okay. Now we got to grow our part a little bit in order to get rid of that stuff. So this thing was 10mm. We're going to have to add some height to it. I make it 12mm tall. There we go. Looking good. We use our sectioning plane there. We can see how much material we've got. And that looks like that's enough. How's it look from the side? Not enough. That's a bit tight. You gotta love these modern tools, man. Let's see. So if we back off a little bit. Oop. Right. A little bit more material back. 29mm. There we go. Ooh. Screws are gonna come up through the bottom. Maybe. Great thing about working in SolidWorks or working in Autodesk or anything like that is being able to check all this stuff early on before you get too far down the road. We're gonna have to make some clearance for antennas, but let's shove this thing in here. First, I'm gonna want to make sure this thing is centered up on our model. So I'm gonna select those two right planes and attach them together. Okay. Now I can only do that. So if we shove the receiver in there, we go to a cutaway view of the side, and we can see what's going on in here. We are not hitting it with the screws. The screws are still about 1/4 of a millimeter below that surface there. So we can shove this thing in here. All the way up like that. All we would need is somewhere to run the antennas out. We could create just a little bit of a channel and run the antennas back the way we went in. That would probably be the simplest thing to do. Run them forwards, but then we'd have to like thread them through. I figured let's maybe just go out the back the way we came. All right, I figured we got about 10:30, maybe about a half hour left. Let's see what we can get accomplished here. Okay, so I'm gonna make another cut here, and it's gonna be a slot like that. Make myself a little construction line. That is basically the center of the slot. And if I snap it to the origin there, it's going to make my slot symmetrical across the origin. And I will set my height. That's going to be the height that those antennas come out. We'll have to figure what that is. And width. There we go. 26. Good enough. Okay. I'm just throwing some values in here just to get things started. Don't think we have to go that far into the model. Let's say like 25. Save. And check out where we're at. Let's make this part transparent. And we can see I've made that cut deep enough. I just think we're probably shallow. Oop, and our height's bad. It is bad. We should probably blow right out the bottom with that thing, huh? You know, if we decase it, this is gonna be a problem. We can just put like a real heavy chamfer on it. And we decase it and we'll be good. So like if we chamfer that and that a little deeper, like so. And we'll make it nice and cozy for those wires, sharp edges. So, right. I want to say the material is probably pretty thin in here. Yeah. Well, I thought it was going to be. All right. I like it. Receiver solved. Maybe we punch a little hole. Maybe we run a slot here to drop the 3-wire harness down to our flight controller. Pass it through a little hole right there. Otherwise, I think we got the receiver location solved. Solid. So last thing's gonna be this guy. Find a place to put this receiver. So I don't know. We should do the smart fin though, right? Is the quad is this a smart fin quad? Spade in the corner tilted. What about a spade on the smart fin? Does that work? Or through? Put a spade and cut it all the way through the smart fin? That's an idea, right? We can't really bury this receiver in TPU. It's just going to melt the TPU. The TPU melting temperature is too low, and these video transmitters get way too hot. So this guy's probably got to go on the underside. Where are the lights? The lights are on this side of the board to show you what channel you're on. So maybe we take the heat sink and attach it to the underside of that carbon fiber there. Like that. Man. Well, we can run a right angle MMCX out of this thing. Right? We put a right angle connector there. We'll be able to find a place to put the antenna. I hate not having everything solved, but maybe we just leave that one for a little bit later. Ooh, you know what? And we can even catch these two holes. Put some holes in this backboard right here, and we'll be able to catch it right there and right there. You know, we could put the spade up here, and the heatsink would show through. Silver, the heatsink would show through. I don't know. I don't think this is a SmartFin quad, personally. I have an idea in the back of my head now that I'm trying to work on this quad. Meanwhile, my brain is gone. My brain has moved on to a SmartFin quad. So I'm juggling two things in my mind at the same time right now. I have an idea what to do with the SmartFin, and it's gonna be fun. It should be Fender Epic. All right, let me edit this and put those two holes in there. Lock that on there. Edit this part. And I'm gonna put a hole feature in 3mm clearance hole. Our holes are screw clearance M3 through all positions. I can't see through the board. I'm just gonna change the wireframe and snap two circles there. And if you see the color is blue, that means they're floating. I'm going to lock them in 30 and a half. Exactly 30.5. So then put that at say 3 millimeters back from the board. And then let's make sure that it is centered up with the little construction line. Oh shoot, I hit the wrong button. Boy, I'm clicking too fast. All right, we gotta wait for it to do its little render thing, and then I can switch back. Okay, please go. All right, thanks. Okay, so I'm gonna delete that last mate, and I'm gonna choose to mate this part based on those holes there and right there. Accepted. Now we just need our spade. I think this top plate still needs a little TLC. Oh, and we still got to figure out how to like make this a snap-in part. Up. It's gonna end up being a pain in the butt to print it, but essentially what we need is a feature like something like that. Something that when we push this TPU part into our carbon fiber, that we get a little hook there to hold on to things. How big is that? I don't know. A millimeter. Millimeter is probably really aggressive. You know what? We can print it big and then we can just snip it off later. If we don't like it. Make sure that this doesn't catch on the hole on its way in. And the rest of it can just kind of float around for now. I don't know. Like that or something. Sure. And I kind of want this little guy to be symmetrical and not that long. Just like that. 8 millimeter clippy deal like that. Let's mirror it across the right plane. That and pop back into our assembly. Okay. So what I'm thinking, it's a squishy part, and you push it through. Once you push it through, these little guys kind of hold on to it. There's probably better ways to do that, but 4 spades. What about a heart, a spade, club, and a diamond for each motor hole on each arm? Huh? Huh? There. Now we're talking. I'm gonna leave those circles. Start wrapping the squad up. I want to fly it. That's ridiculous. Whatever. We'll live with it. And we're gonna punch our spade through here. It's a good way for drawing spades on about yay tall. Attach that there. The base of our spade, 3 millimeters. I know what a spade looks like. Eh, something like that. Right? Then we need a thingamabob there. And then something like that. Right? How do we connect those? This is a terrible, terrible drawing program. As far as like being free to make a creative thing like this. Stretch the line up here. I'm unsure if this is gonna work. Oh, that's not what we want. Stop doing that. Okay, that's something. That's certainly something. I don't know. Let's try punching it through. Let's see what the heck it looks like. I don't like. What don't you like? Geometric conditions. It doesn't like certain geometric conditions. Maybe we gotta do some trimming here. Trim. Are you tangent? Ooh, that was the geometric condition. Didn't like. Yep. I know that right now. Try her again. Think. There she is. All the way through. Oh man, that's nice and sharp right there. Okay, so we gotta. Cutter's only gonna go so far in there, so. Oh, where'd my thing go? No, we're not doing the search. Like 4 inch. Well, not as cool with the cutter in there, but something. All right, your chat. I don't know if your chat's still actually delayed. Probably not. I just have a hard time looking over at my chat screen. My chat window's on the other monitor, and I don't pay attention to it as much as I should. Like so. That's spade-like. How's it look on the main assembly? That works, right? That works. That'll be all shiny because that's like the heatsink. That's the heatsink of the VTX right there. That'd be cool. It'll be all right. We just gotta get real creative with that antenna clearance out of there, right? Doing the side pipe. I don't see a real good place for the antenna just yet. I don't know. Sometimes it's just good to make the prototype and physically play with that antenna location. Sometimes just looking at it in CAD isn't quite enough. You gotta print some of these parts out, grab an antenna, and throw it on there and see what happens when you start bending that coax around where it wants to go. You know, it would be great if the coax was long enough to come across the flight stack, turn, and like put the clover leaf like as a side pipe right here or something. I don't know. I don't know. It's good to get those antennas away from the carbon fiber because you can really give yourself like a dead spot when the antenna you're flying and the antenna is on the other side of the carbon fiber from you. Your signal's terrible. But that's why it's good to get the antenna away from the carbon fiber so that no matter what orientation the quad's in, you have like a clean line of sight from your ground antenna up to your aerial antenna. Cool. I think so. We take 3D print this little guy. We could probably clean him up a little bit, right? Maybe trim. No, leave it. Right? Yeah. I'm gonna leave that alone. I was gonna say we could do something, but that's fine. I don't think that's too bad. What do you guys think? We did okay for today. You guys see any other suggestions for me? See anything maybe we could do with that VTX differently than what I'm thinking there? We could probably bring this back a little bit tighter to the quad itself. We could probably shave. We could shave at least a millimeter off there, right? 2 millimeter. Oop, oop! Don't do that. My spade didn't move. Put my spade back together. There we go. All right, we'll just leave that. We need spade. We need a little bit of room for that spade. It's clearing. That's rubbing. Let's fix that real quick. Back that up to 17. Should be flush with the front of our part there. So that doesn't look too bad. And we're not hitting anymore. Okay. When does it hit? So the wiring harness hits right there. So that would be as flat as you can make your camera. And how flat is that? Measure 25 degrees. I don't know. I think everybody's flying 25 degrees right now. If anyone needs to be flatter than that, they can screw around with it themselves. I think we're all right. We're clearing the boards. Yep. Okay. Battery strap is good to go around there. I don't know. We'll see how it goes together. It might be a mushy mess up there. It might work. I don't know. We might need 4 of these little hooks. We might need a front one and a rear one. Just to make sure that guy's stays put, but overall, I think we're all right. You know what? That TPU part, we should be able to like pinch it and put it through, and it'll open up. And once you put the screws up in, once you add these screws in there, it won't be able to collapse that much anymore, which means that those hooks are likely to keep that carbon fiber plate in place. That's good. All right. So what's up, everybody in chat? Anything else that we should hit up? I think that top plate's a little chunky looking. I don't know. It's appropriate because it kind of covers the VTX and it gives us a little bit of meat around the camera, but it's a touch chunky looking, I think. But not bad for our first stream quad. Not bad at all. Shave a little material out somewhere. But I think we're pretty good. pretty good. I think Chad did a good job designing this quad. Not bad. Not bad, guys. We'll throw a sheet of 2mm carbon fiber on the CNC, get that top plate cut out, and we'll 3D print out our little I don't know, our little battery strap guy up there. I don't even know what you call this part up here. That's kind of a new thing. A different TPU block. Havelock is suggesting another TPU block. This one for putting your session on top of this quad. I think that's not a bad idea. Have a session mount built in up there. I don't know. Is that too much weight to be tugging on the standoffs with the whole session up there? Kind of the way that we designed this, right? Right, putting a session up there, I think I would want to run like external standoffs down around the outside of the flight controller stack, which we should probably do anyways, but I think we keep this. We're gonna keep this build simple. We'll run right through this stack and see how it goes. I don't know. Who's gonna do our destructive testing on this thing? Who's our gate crasher? Who's the gate crasher in Buffalo Multi-Rotor that can do some destructive testing on this thing? I think that's Mark. I think that's Pryor. I think we give him the Bull FPV camera and let him have it. 5-cell. See how long it takes. Pryor says Quest for destructive testing. This is true. He can be loose. That's right. Mark is right. He says Quest breaks gates. If I recall, Quest flew straight through our scheduled 40 PVC pipes last year. Like they weren't even there. Yeah, after Quest flew through that PVC and just cut it right in half, I went in and just did the math on these quads because that's that's a lot of force. I mean, I think you can swing a baseball bat at a PVC pipe and probably not break it. But if you do the math, if you get one of these quads flying at 70, 80 miles an hour, they've got the same amount of energy as a bullet. So once I saw that those two things were similar, yeah, it was pretty obvious why it went straight through that PVC pipe without thinking twice. That's a lot of energy behind these things. You got, I don't know, a 500-gram quad going 80. A lot of energy. Takes a lot to stop a quad like that. It seems crazy. Like the propellers are the most dangerous thing, and I can confirm that the propellers are dangerous, but they're most dangerous on the ground. When that quad is moving at 80 miles an hour, it's not the props that you have to worry about. It's the weight. It's getting hit with that much weight at 80. That's the problem. That thing would, these things could do some damage, man. That's crazy. I'd love to see one of the 200-mile-an-hour builds. Havelock says he's not the fastest, but he's definitely destructive. I don't know, man. Havelock, you've been flying pretty tight this winter. No. Who else? Everybody's in a fight for second place behind Benny Mac, and man, Havelock, you've been crushing it this winter. You're really giving Onyx and Fender a lot of work to keep up with you. I don't know, you're getting a lot of practice in this winter or whatever, but it's been pretty tight racing for second place. And you're kind of out in front of the pack right now. You secured that second place for the season and second place for the championship. You gotta come down to the new track and see if you can fly the smaller gates. We got the tiny whoop spec gates set up at the new track, so totally a little bit of a different ball game there, a little tighter. Josh was able to weave his 2-cell through those gates, and he was able to do it pretty well. He's definitely showing the parking lot practice that he's been doing, and I can't wait to see everybody this summer too after parking lot practice. Parking ramps are tough. I don't think there's any simulator that I can fly the parking ramp levels. I feel like everybody else that I make fun of is just like ceiling, floor, ceiling, floor, ceiling, floor. Benny Mac says he's whipping up a batch of his Benny Mac whoops, his BM whoops. I think you should run with the BM whoop thing and make the little poop emoji for the BM whoop. That would be pretty tight. Avlock, I'll make it. Probably only 3 or 4 races though. That's cool. That's, hey, whatever you can do. You know, went from one extreme to the other. We were way up in the North Towns, now we're way down in South Towns, but I don't know. You get a couple of weeks where some of the South Town guys don't have to travel so far. And yeah, if you guys make it out to a couple, that would be cool. So I was looking for a place that we could set that I could work on the baby bando track and spread out, get some of this stuff built. Because these like miniature silos, these scale silos are gonna be, they're large, and I'm running out of room for stuff. So it's good to have that place over there. So, anyways, there's the old silos. So I got a little bit of work to do. We got like some details and stuff I gotta put up here, but got my tubes, MDF, 1/4-inch MDF on the laser to make the little hut on the roof, and we'll have ourselves these little silos. So there's our stream quad. Make sure that's saved. Cool. And what was the other thing we were looking at? Multi-GP track. So as soon as the fields dry out, man, it's time to get this stuff set up. A lot of flags on this. It's a pretty cool track, I gotta say. I designed a track for us this summer too, and it's the same length. It's another 1,000-foot track. This is cool. You're gonna come off the starting blocks, hit the slalom, right? Hard left over the hurdle, back down, around this corner flag here. And then you got to do this little corkscrew guy here. So you got two gates, hurdle in between that you got to get over the top of. So you got to get through here, corkscrew this thing, hit this far gate, and then do this ridiculous turn here that's kind of like Nautilus, right? So you got to go blow past this gate, turn around, come back, get on the outside of these flags, and then make a huge sweeper back to the start-finish gate. So that's gonna be a lot of battery, but as you guys know, this year it's open class, so 4-cell, 5-cell, 6-cell, whatever you guys can get slapped onto a quad and be under I think multi-GP spec is like 800 grams, so you could throw a 6-cell on there and a session and still be underweight. So Havelock, I'll be out every week once the spring hits. Yeah, be fun. I got big gates and stuff to build this summer. Be cool. Looks like we hit our 2 hours. 11 o'clock. Matt Fender says it's a fun track that he's tried it on liftoff. I gotta download it and try it out. What am I on? I think I've got Velocidrone on the new computer. 20 frames per second on liftoff. Yeah. Even Velocidrone, I don't know. You get used to like AAA titles, right? That look beautiful and run at, you know, pretty good frame rates. And then you got, these games that, I mean, the guys have put a ton of work into them, and you got to give them a lot of credit. But it's tough, man. You get a decent computer doesn't hit very high frame rates, but they don't have budgets of $100 million for the next Call of Duty type of thing. I think they're doing pretty good with what they've got. I mean, DRL is putting a lot of work into their simulator. I think they're gonna put probably a lot of weight on the simulator as like a kind of a main part of DRL will be that sim. So I expect to see a lot of that one. They've got the money behind it. May not, may not fly the best, but I expect to see a lot of development there. Benny Mac trying to stay WFO. Benny Mac, what's WFO? I don't know what WFO is, Benny Mac. Trying to stay. Maybe I need some more 11 o'clock coffee. All right, guys. That'll do it. I'm going to wrap this up for tonight. And yeah, we'll catch you guys next week. I think next week I get these parts cut out and we do a build on the next stream. So we'll pull some motors. Maybe you guys figure out what motors we should use on this guy, and I'll pull whatever, what a 20 amp 4-in-1, and I don't know. I got a whole bunch of Luxes in stock because people didn't seem to like that board, so maybe we throw a Lux in there. I gotcha. Betty Mac says wide effing open. I want to see some Benny Mac outdoor flying to match Benny Mac indoor flying. That's your goal this summer, is to show everybody that Benny Mac is not just the king of the indoor track. Benny Mac is the king of all tracks. And then when JT comes strolling back in after his Sebring high, Benny Mac would be like, "What?" Put him right in his place. That's gonna be tough because he's third place behind the two fastest pilots in the world. It's gonna be a fun summer. I can tell already, guys. It's gonna be fast. All right. Well, that's it for me. Figure out a good way to sign off one of these days, but yeah, I'll catch up with everybody over the weekend. What do we got? It's Thursday, Friday. Friday we're doing a little whoop race with the Flying Knights in Hamburg. So any of the there's a bunch of guys in Buffalo Multi-Rotor that are Flying Knights, and that's like the AMA club in Hamburg, right? So that's like Lone Star, Barf, and Pizza Hut and all those guys, right? So we're gonna be doing a little whoop race tomorrow night, and then Saturday I'll be over at the new track for most of the day, putting the probably painting the towers blue. Tomorrow morning I'm working on Delta 5 timers. So I've got a stack of Raspberry Pis, a stack of Nanos, a stack of those RX 5808s, and so my buddy Marty, he's coming over, and we got a whole bunch of soldering that we got to do. Get those Delta 5 timers up and running. One of the things we got to do is design cases for those things. So we can put those out on the track, something waterproof, weatherproof, something that's not going to get too hot sitting in the sun and stuff like So I gotta work on that. So yeah, timers, bandos, all kinds of cool stuff happening. So I'll catch you guys this weekend. All right. See you guys.